How we doing? Here we go. So today we have 2.6 notes, which is going to be stretches and compressions. First thing we're going to do is graph our equation just to get us used to it again. Our equation is 3x plus 7, where 3 is, of course, our slope, and 7 is our y-intercept. Okay. The first step we have whenever we want to graph a line is we are going to plot a point at our y-intercept, which in this case is going to be 7. We cannot create a line unless we have one additional point. So our slope is 3, so we're going to go over 1, up 3, over 1, up 3, over 1, up 3, over 1, up 3. Give us a few points there. Use my ruler. I'm going to connect all those points. And there is our line that represents the equation 3x plus 7. Now when it comes to plotting lines or graphing lines, pretty much 2 steps here. Step 1 is going to be plot the y-intercept. And then step 2 will be use the slope to find additional points. Okay, cool. So let's get into what this lesson is all about. So today we're going to be comparing all of our changes to the graph to the parent function, which is f of x equals x. The slope of the parent function is, of course, 1, and since there is no b value, it's going to be 0. And we've already graphed it for you. So now we're going to graph the second one. This 2x here tells us that our slope is going to now be 2, and our y-intercept is not affected, so it's still 0. So now I'm going to plot my point. My y-intercept is 0, and my new slope says 2. So over 1, up 2, over 1, up 2, over 1, up 2. I'm going to do a few in the other direction. So down 2, over 1, down 2, over 1, down 2, over 1. And then I'm going to connect these dots. Okay. Notice that my line kind of rotated about the origin, I guess, the x-axis or the x-intercept, and it made it go steeper, or you could say it was a vertical stretch. Okay. We'll do another one. We have the parent function, the linear parent function again. So we have a slope of 1. We have a y-intercept of 0. So now instead of changing it to 2 like we did on the previous one, we have 4x. So that means that our slope is now 4. Our y-intercept is 0. So our y-intercept is not changing. But now instead of going over 1, up 1, we will go over 1, up 4, over 1, up 4, down 4, over 1, down 4, over 1. Connect the dots, and there you have it. Now notice, whenever we change it to a 4, it's going to be steeper than it was when we just changed it by 2. So the larger the number, the steeper it will end up getting. Okay. How are the graphs similar? How are they different? So the first thing that we have here is we're going to have the same y-intercept. Okay. And they're both steep. On the previous page, we changed our slope with numbers larger than 1. This time, as you can see, we have numbers less than 1. So we have 1/3 and 1/4. Nothing's changing with our initial equation. So we have the parent function, which is a slope of 1 and a y-intercept of 0. And then we have a new slope, which is right here, of 1/3, and our y-intercept is not changing, so it's going to stay at 0. Okay. Now this time we still have the same y-intercept, but it's 1/3. So we're going to go over 3 up 1, over 3 up 1, over 3 up 1. Give ourselves a few points in the other direction, down 1 over 3. And then of course we are going to connect those points. And clearly it was moved downward, so it's going to be less steep. The closer you get, so you multiply by 1/3, which is getting closer to 0. A perfect horizontal line has a 0 slope. So the closer your number gets to 0, the less steep or flatter it will get. All right. The next one, same thing, 1 slope, 0 y-intercept. Now we're going to change our y-intercept to, our slope to 1/4. Our y-intercept maintains the same, so we have a 0, 0, over 4 up 1, over 4 up 1, down 1 over 4, down 1 over 4. Connect the points. As you can see, it's a tad bit flatter than the last one because 1/4 is smaller than 1/3. Okay. As far as similarities here, we have the same y-intercept once again. And then both are less steep. Now we're going to get into the negative. So we all know that this is a positive 1. This is a 0 y-intercept. All right. So we know that the positive x's go in the positive slope direction. So now that we introduce a negative, so now we have a negative slope, which that's just going to turn that into a -1. It doesn't affect your y-intercept, so it's going to maintain 0. And so instead of going up over 1, up 1, over 1, up 1, at this point we're going to go down 1, over 1, down 1, over 1, in the negative direction, which is to the bottom right. Right. I'm going to connect those dots, and there you have it. So originally it was pointing upward. Because we multiplied by a negative, now it is pointing downward. Okay. 11 and 12. Now the negative's on the outside, but it's still going to treat it the same exact way. So we have a slope of 1, a y-intercept of 0. Now our slope is now -1. Right? And our y-intercept is still 0. So it's going to look the exact same. There we go. So the way we describe that is going to be same y-intercept, and we had a reflection. We call it a reflection because it went from a positive slope to a negative slope. Alright, so you'll notice that on this page we've moved our fractions and our whole numbers to the outside of the parentheses. As far as y'all are concerned, at this level, there is no difference. So let's just go ahead and take a look at everything. We have our linear parent function, which is a slope of 1, a y-intercept of 0. Now we were changing our slope to 1/3. We are changing our y-intercept, or we're not changing our y-intercept, so it's going to maintain the same. Right? We're going to go down over 3, up 1, over 3, up 1, over 3, up 1. And yes, it will look identical to the previous page where you did the 1/3. And as you can see, it flattened out or became less steep. Right. We have 1/2, so we have our parent function 1, 0. Our new slope is 1/2. Our new y-intercept is still 0. We start at 0, 0, over 2, up 1, over 2, up 1, over 2, up 1, all the way over. We'll go down in the opposite direction, down 1, over 2, down 1, over 2, down 1, over 2. Cool. And as you can see, it flattened out there. So, just like before, we're going to say same y-intercept, and then is, of course, less steep. Alright, and then moving on to the whole numbers. So at this point, you should recognize that if you multiply by a number less than 1, we're going to get less steep or flatter. If we multiply by a number greater than 1, it's going to get steeper. So let's just go ahead and observe that a couple more times here. Y-intercept of 0, or sorry, slope of 1, y-intercept of 0. Our new slope is 2. Our y-intercept stays 0. So over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2. Same thing in the opposite direction. And we'll connect those dots. You can see that it moved closer to being a straight up vertical line, so it got steeper. And the last problem. We still have your your slope for the linear parent function of 1, y-intercept of 0, a new slope of 3, and a y-intercept that still stays at 0. So 0, 0, over 1, up 3, over 1, up 3, over 1, up 3, down 3 over 1, down 3 over 1, down 3 over 1. We're going to connect the dots. We can see that it shifted to be steeper. All right. And then our observations look much the same. Same y-intercept, and it is going to be steeper.